All right, we're going to talk about solving linear equations. How many of you think you can already solve a linear equation? Darian says he can solve them. Equations. All right, so to understand solving linear equations, we first need to understand some opposite operations. Do you know what I mean by opposite operations?
Addition, subtraction.
Absolutely. Addition and subtraction, why do we call them opposite?
They're opposite.
Why are they opposite?
Because some take away and some don't.
When we're thinking in terms of equations, what do they do to each other? Cancel each other out, right? If I add 2, but then I subtract 2, that cancels each other out. So we call them opposite operations. What is another set of opposite operations? Multiplication and division. So those are the two we're really going to be focusing on, the two sets right now. But we will definitely get to some more soon. I'm going to pause this. Remember, when we're solving equations, our whole goal, and I think DeAndre said this earlier, was to what? What's our goal?
Simplify.
What about the variable there? Get it by itself. I'm going to put X in quotations because we'll have some different variables, but we want to get it by itself. So to do that, we use these opposite operations to get rid of everything except the variable, right? Right. Yes, yes. Tell me what's being done to X right there. What's happening to X? You do have to divide, and you have to divide because why? What is happening to X? You got to get X by itself, but what's the 2 doing to X? It's multiplying, right? And we said the opposite of multiply is to divide. So what I need to do is whatever's being multiplied there, divide, right? Because multiply, divide are opposites, so that cancels each other out, and I'm left with 1. Yes? Does that make sense? I know this is easy. That's a one-step linear equation. There's only one thing being done to X, so there's only one step to get rid of it. Same concept if I were saying 2 plus X equals 8. How do I get X by itself now? Subtract the 2 from both sides. Is that confusing to anybody? Okay. All right, so let's talk about if you really understood our fractions yesterday. Ooh. So you've already told me when there's only one operation, I do the opposite operation to get rid of it, right? What's happening here? It's being multiplied to X. So the opposite of multiply, we said, is divide. So let's think about this a minute. I know that I need to divide by 2/3. Do we all agree with that? Yeah. But what did we talk about yesterday? We don't divide by fractions. What do we do? Multiply by, good job, by the reciprocal. So what I want to do to get rid of this, because dividing by 2/3 is the same thing as multiplying by the reciprocal, yes? Do we all agree with that? So now, oh, those are gone. So it's just X. How do I multiply fractions?
Straight across.
Straight across. What do I get? What's a half, or 1/4 times 3 halves?
3 over 8.
3 over 8. Does that make sense to everybody? So those are one-steppers. Those are pretty easy. Let's talk about some multi-step equations, which you already know how to do. So what's happening now is there's more than one thing that's being done to x. And I'm going to start easy. In fact, this will probably look a lot like your warm-up that we did this morning, okay?
It is.
Is it the same one that I remember? Oh, go me. Okay. So my question to you is, you knew what to do, but why did you do that? In other words, when you worked that problem, you added 1 to both sides. Why did you do that first? Why did you not divide by 2 first?
You get 2 X won't be by itself.
It has something to do with a very, very, very important concept in math.
Did that go off?
Do you know? Does anybody know? Yes. It absolutely is. Good job. Kudos to you. It is because of the order of operations, okay? But we're not going in the forward order of operations because what we're doing when we're solving is we're undoing stuff. So instead of going, do y'all know the order of operations? PEMDAS, right? Please excuse my dear Aunt Sally. Instead of going forwards because we're undoing, and this is really important, and you'll hear me say it a lot, we go SADMAP. Okay? Does that look funny to any of you? Okay, somebody said very. All right. First of all, it's backwards, right? We all recognize that. But the other thing is, I hope that your teachers in the past have emphasized that addition and subtraction and multiplication and division have the same weight, so to speak, when we're looking at equations. Do you understand that? Because what we do is the addition and subtraction, it's whichever one comes first, left to right, right? When we're simplifying. So that's why we write them together that way. So when we're solving, we're going backwards, we're undoing. So the first thing I want to look for is there any addition or subtraction being done to x? Yes, what's being done? I'm subtracting. So that's how I know to do that first. So then I do the opposite, and the opposite of subtraction is addition. And if I do it to one side, I have to keep my equation equal, so I also do it to the other side. So this is gone. I have 2x equals 6. So now I'm done with addition and subtraction, right? Now it's multiplication division. Divide by 2, because I do have multiplication here. It didn't change colors. So to get rid of that, the opposite is division. So I divide by 2. And I get x equals, I'm out of room. X equals 3. Tell me this while some of you are copying that down. If I wanted to check to make sure that answer was right,
Do the opposite.
what could I do? Plug it in. Plug it back into this equation that you started with. And if you get an equal, a true statement, then yes, your solution did work. All right, y'all ready to move forward?
C.
All right. Let's look at one that's got some parentheses in it. Let's say it equals 4x. x. Now this one's special for two reasons. Tell me one reason it's special. Yes. The parentheses are there. That's definitely different than what we've been doing. What else is different about this equation? It's got an x on both sides, okay? What should we do? Distribute. Everybody always wants to distribute. I would tell you to try when it looks like this, or you have parentheses, to always try to simplify both sides first. Okay? And we will get to some later, and we'll talk about how we can solve. There's another way we can solve without distributing first, but for right now, let's focus on simplifying both sides before we start. Okay? So on the left side, well, let's simplify the left side first.
Plus 2x.
6 plus 2x. Now we have a problem because we have more than one x. So what are we going to do?
Subtract 2x from what?
We want to gather all the x's together on the same side, right? And that's, you were right. You were absolutely right. So I want to get the variables together. So to do that, I have to undo, oh, the phone is ringing. So we want to get those variables together. So to move them, we have to do the opposite to get rid of them on one side, right? All right. So which one should I move? Should I move the 2x or should I move the 4x? Why?
It'll be positive.
Absolutely, it'll stay positive. If you always move the smallest one, it's going to keep you positive, and we like positive, right? So everybody's yelling to move the 2x. And I know I'm going kind of slow, and y'all know how to do most of this, but need to make sure. What's 4x minus 2x?
2x.
Good job. Don't forget, the 1 is still there, yes? Now I look like what I've been doing with my multi-step equations, and I am ready to get x by itself, so I need to go in what order? Subtract it, because I'm going SABMAP. I'm going to keep writing it on here until y'all remember it. SABMAP. All right, so addition, subtraction first. What do I do? Subtract the 1, absolutely. Does it matter that the x is over here instead of on this side? No, absolutely does not. All right, 6 minus 1. Good job. This is gone. What now? 5? 2. No. Leave it as a fraction. Fractions are our friends. Yes, fractions are our friends. We love fractions. Leave it as an improper fraction. Don't change it into a mixed number. Just leave it just like that. Yay or nay?
Shay.
Shay. All right, so let's look at number 1. I'm on this side with the 9m. Remember I told you the variables could be different? So what we're going to do is we start with equation number 1. And you're going to use the answer from number 1 to help you find the answer in number 2. Okay? So the first thing I have to do is solve number 1. All right. See, this one's a little bit tricky, and it's a little bit tricky because there's a minus sign sitting here in front of this 3. And I want you to be very, very careful of that, okay? So the first thing we do when we see these parentheses like this is we should probably what? Distribute and simplify each side first. I say be careful because notice here, you're distributing a -3 and not just a 3, okay? Somebody said same, change. If you want to change this to plus -3, you can, and you can distribute a -3 through there, however you'd like to do that. All right, so on the left, I end up with 9m. Can y'all see that color okay? No. Let me change here. 9m plus negative 3m. What happens here? Negative 3 times 6 is, come on, y'all. Negative 18. If you didn't do plus negative here, you'd have minus 3m and minus 18. Either way is fine. How about the right side? What happens to the right side? Absolutely. 2m, and then you multiply the 2 and the 1 to get 2. Now my left side is still not simplified. Why? I've got some like terms there, right? 9m and negative 3m. If I combine those, what do I get? A number, yes. 6m, very good, very good. Now here's where you might get a little bit confused if you change that to a plus negative, because I'm really subtracting, so I got to remember those opposite operations, right? But the first thing I want to deal with is what? The m's. I always want to take care of those variables and put them together. Good job. Tell me why I'm subtracting 2m and not 6m.
Because that's a smaller number.
It's the smaller one. I always want to move the smaller one. All right, so on the left, I have what? 4 what? M, good job. I'm going to go ahead and change that to 18 instead of plus negative 18. Equals 2. Good job. Now what? Careful. Add 18, because here I'm subtracting here, so the opposite of subtraction. But remember, I told you if you had done this, you might be a little confused as to what to do. So you might want to make sure it stays subtraction so you see. All right, so plus 18?
So that'd be 4m equals 20. Then you divide by 4 on both sides.
When you added 18 here, why did you add 18 first?
Because you're trying to get 4m by itself.
You're trying to get n by itself.
Yeah,
M by itself, right. So you use the what? What?
You use the opposite of
SAD.
yeah.
The opposite of the operation, but you went in the order of SAD map. Okay? Which is why now I'm taking care of the multiplication division. Like you said, where we divide by 4. So what is M? 5. All right, so if you look on your sheet, there's a blank here where it says answer M equals blank. Okay? So you would write a 5 there for what M equals. Does it make sense to everybody? Okay. Then we go to problem 2. Oh, problem 2 is, it's not as bad as it looks. You have to use your 5 and plug in before you can solve though. So problem 2 says 14 minus x plus m equals 3 x plus 9 minus 10, right? And you don't have to rewrite that when it's already on your sheet. Well, we look back, it's called a relay because we're going to tag to the next person, but we have to use what we got from answer number 1, which was m equals 5, okay? So you're going to plug this 5 in for the m in the problem. Does that make sense to everybody?
Yes.
All right. So my problem is actually now 14 minus x plus 5 equals 3 x plus 9 minus 10. Now, as you go through these, you will probably want to plug back in and check your answers, because if you get the answer wrong in number 1, it's causing the answer to be wrong in 2, 3, and 4, right? because then my equation differs. All right, so I've got some parentheses, some grouping symbols there. What should I do first?
You should just put, you can think of the negative as like -1.
Absolutely, good job. That's a -1 in front. So I'm really distributing a -1 through. So what's my equation look like now?
So
14 minus 1.
Yeah.
14, y'all said that really fast. 14 minus 1x minus 5 equals
3x plus
27, very good, minus 10. Before we get into SADMAP and we start actually solving, let's clean it up a little bit. Yes?
27 subtracted by 10, you get 17, and then
These two you said are 17?
17, and then you're gonna add,
Look at that left side, yeah.
You're gonna go, the way I did, I just did it longer, but I didn't put the 2 before.
Did you go through and subtract 14 and add 5?
Oh, yeah, that's what I did.
Yeah. Which is, it's not wrong, it's just a step more work. So if we clean it up a little bit first and combine those, 14 minus 5 is what? 9. And I got that minus x. I'm still not quite ready to start SAD mapping yet because I don't have all my x's together, right?
Right. So it'll be,
Which one are you moving?
Subtract the 9 to 17, so you get 8. and then
Well, you're moving numbers first. Let's move the variable. That's not wrong, but let's.
Move the
What's the
-1
X?
x first.
Why?
Because
Make it
that's
9
the
alone.
lowest number.
So it's positive.
This was the smallest one, so I moved it. What is 3x and x?
4x.
Now I'm ready.
Subtract 8. It's gonna be
Well, you're gonna have to,
-8.
you want to subtract the 17, you're gonna get -8.
Subtract the 17.
I don't know what negative.
Because again, SAD map. Subtract the 17, and you said I get what on the left?
You get 8 on the left.
-8.
So you're gonna divide 4x.
And divide by 4, absolutely.
You get 2. -2, right?
You absolutely, you get -2. So that's the answer to problem 2. But now I have to go to problem 3 and plug that x value in and then solve for y. Okay, do y'all get the pattern here? Do you see what you're doing? All right. Let me pause this.